Hello students. Today we will explain about the characteristics of a full wave rectifier. In the previous class we discussed about the operation of full wave rectifier and we explained about the input and output waveform. The characteristics of a full wave rectifier. Here we need to calculate 6 characteristics for this full wave rectifier. First one is efficiency. So we need to find out a percentage of efficiency. How much AC signal is going to be converted DC signal. Next, ripple factor. Ripple means unwanted AC components at the output signal. So you need to find how much percentage of ripples is at the output. So you need to calculate percentage of ripples at the output signal. Next, peak inverse voltage. Peak inverse voltage is the maximum reverse voltage before the breakdown condition. Transformer utilization factor. Transformer utilization, how much percentage of transformer we used in the power supply. So we need to calculate that TUF, how much percentage of transformer utilizing in the power supply. Next form factor and peak factor. These are the six characteristics we are going to be find out. So before going to calculate all these 6 characteristics, first we need to calculate average voltage and current. Average value of voltage and current. Next, RMS value of voltage and current. Average value of voltage and current means we got the output voltage and the output current, right? So simply average voltage and current means output voltage and output current. Next, RMS value. RMS value means this RMS value calculation is for input voltage and input current, right? So first we need to explain about this and after this one. Average DC voltage and current. Average voltage and average values of voltage and current means output current, right? Output current or output voltage is in the form of DC condition. So that is why V average is equals to VDC. VDC, and the formula is 1 by pi integration 0 to pi V naught d omega t. This is the formula for average DC voltage VDC. So you have to remember this formula, right? So VDC equals to 1 by pi integration 0 to pi V naught d omega t. Next, 1 by pi as it is, integration of 0 to pi. So here V naught formula, V naught is equals to 2 Vm by, V naught is equals to 2 Vm sine omega t, right? So 2 Vm sine omega t is from, the limits are from 0 to 2 pi. So here I am taking only from 0 to pi, only one peak, positive peak. So that is why I am taking single Vm sine omega t. So instead of V naught, Vm sine omega t d omega t. Next, this Vm this Vm is taking outside, out of the integration, then Vm by 2 pi. Next, integration of sine omega t. Integration of sine omega t minus cos omega t. Minus cos omega t. Applying limits 0 to pi. Okay. Next, I am taking this minus is out of the bracket, minus Vm by pi. So apply limits here. First apply upper limit minus, you can apply lower limit. So cos pi minus cos 0. Minus Vm by pi, cos pi value is minus 1. So here cos pi value is minus 1. Cos 0 value is 1. So minus 1, this minus and 1. So VDC equals to, here this total form minus 2. We got like minus 2. So minus into minus plus 2 Vm into 2 Vm by pi. So VDC value, average output voltage value is 2 Vm by pi for full wave rectifier. Have you remember for half wave rectifier? For half wave rectifier, this value is Vm by pi. Now this average value is doubled, right? Okay. So similarly, average current value to Im by pi. Average current value to Im by pi. Right? So average voltage and current values are calculated. And then next go for RMS value of voltage and current. RMS values are calculated for input voltage and input current, right? Okay. This is the formula for VRMS. VRMS is equals to under root 1 by pi integration 0 to pi V naught square d omega t. So here root mean square means sorry, here RMS V means root mean square. So square root mean square of the output voltage, right? Next, V naught. Instead of V naught, we know the formula for V naught. So V naught formula is for only limits are from 0 to pi. So that is why I am taking Vm sin omega t. So instead of V naught, we are just simply writing like Vm sin omega t. So here V naught is having square. So that is why formula is also having square. Vm square sin square omega t d omega t. Next, so here I am taking this Vm square out of the integration, right? Vm square by pi, remaining terms, integration 0 to pi, sin square omega t formula. Sin square omega t formula 1 minus cos 2 omega t by 2. So 1 minus cos 2 omega t by 2 d omega t. Next, in next step, simply Vm square. I am applying square root for this Vm square. Now we got Vm. Vm. Next remaining terms, 1 by 2 pi. I am writing this 2 out of the integration 1 by 2 pi. Right? Next remaining terms. What are the remaining terms now? 1 minus cos 2 omega t. So you have to apply integration for 1 and integration for cos 2 omega t. Right? So first apply integration for 1. Integral 0 to pi 1 d omega t minus integral 0 to pi cos 2 omega t d omega t. In next step, Vm as it is square root 1 by 2 pi 1 integration of 1 integration of 1 with respect to dx with respect to x, then that is x. Okay, so here we are taking integration with respect to omega t, so that's why integration of 1 is omega t, and after applying integration you need to apply limits also. From limits are from 0 to pi. Next, minus cos 2 omega t. Cos 2 omega t formula is sin 2 omega t. Next, again you have to integrate for this part 2 omega t. 2 omega t. Integral of 2 omega t is 1 by 2. So finally we got sin 2 omega t by 2. Limits. You need to apply limits from 0 to pi. Next step, Vm as it is, square root 1 by 2 pi as it is. So here applying the limits. First apply upper limit minus lower limit. So pi minus 0 minus. Here sin 2 pi. So here I am writing 0 directly. How to get 0? Listen careful. Sin 2 pi. Sin 2 pi by 2 minus sine 0 by 2. Okay. So here I am taking 0 directly. Okay. How it comes? Sine 2 pi by 2. Applying the upper limit. Sine 2 pi by 2 minus sine 0 by 2. Sine 2 pi value is 0 minus sine 0 value is 0. So that is why this total term as 0. So for this total term I am taking 0 directly here. Okay. Next, Vm under root 1 by 2 pi, pi minus 0 as pi minus this 0 is like pi minus 0 as pi. So pi pi gets cancelled. Finally we got a Vm by root 2. Vm by root 2. Okay, so V RMS value is Vm by root 2. Similarly, current equation, that is I RMS is equals to Im by root 2. Have you remember in a half wave rectifier RMS value, V RMS equals to Vm by 2, I RMS equals to Im by 2. So after taking these two values, then go for the calculation of all these factors, 6 factors. Okay, right. So first factor is efficiency. So before going to calculate all these things, we already find out DC values of voltage and current, average voltage and current. So we got average voltage formula is 2 Vm by pi. Average current value, that is 2 Im by pi. Okay, and also we find out RMS value of voltage and current. VRMS value is Vm by root 2. IRMS value is Im by root 2. Okay, so we find out average voltage and current, RMS value of voltage and current. So you should remember all these formula for next simplification, right? Efficiency, first factor is efficiency. You know what is mean by efficiency is the capacity, how much percentage of a AC signal is going to be convert DC power. Formula, the ratio of output DC power to input AC power. Okay, so neta equals to output DC power means PDC by input AC power means PAC. So here PDC formula, this is the formula. PDC formula, PDC equals to, formula is VDC square by RL. PAC formula, input AC power, PAC formula VRMS square by RL. We know formula for VDC and VRMS. Substitute these things. VDC formula and VRMS formula. VDC formula 2 Vm by pi. So here VDC square, right? So that is why total VDC formula whole square by RL. Next, VRMS formula Vm by root 2. VRMS formula Vm by root 2. Total formula whole square by RL. Substitute these two formula. Substitute these two formula in this equation. Neta is equals to PDC by PAC. Okay. So here 2 Vm by pi. After simplification, we got 4 Vm square by pi square RL. Next, after simplification, we got Vm square by 2RL. So substitute these two things in neta equation, efficiency equation. Then 4 Vm square by pi square RL whole divided by PAC. We got PAC Vm square by 2RL. So here the cancel terms, RL gets cancelled, Vm square cancel. Right. So this 2 is here and this pi square is 2 here. Then totally we got 8 by pi square. 8 by pi square value is 0.812. 0.812. In terms of percentage, 81.2 percentage. So the efficiency of a full wave rectifier is 81.2 percentage. Whereas in half wave rectifier, the efficiency of half wave rectifier is we got only 40.6 percentage. So compare these two rectifiers, half wave rectifier is having less efficiency than the full wave rectifier. So that is why we use full wave rectifier is in the practical way. Next term is a ripple factor. You know the meaning of ripple factor. Ripple means unwanted AC components at the output side. So we need to find how much percentage of unwanted signal is at the output side, right? So here we have the formula ripple factor. For ripple factor, gamma equals to the ratio of RMS value of AC component to DC component, right? So RMS value of AC component like VR RMS by VDC. So here again, VR RMS formula is square root VRMS square minus VDC square, right? So VR RMS formula is this one. Okay, substitute this VR RMS formula into this equation. Then VR RMS instead of VR RMS under root V RMS square minus VDC square by VDC. After this equation, take VDC common from this numerator. Then after simplification, finally we got VRMS by VDC whole square minus 1. Okay, so finally we got gamma equation is under root VRMS by VDC whole square minus 1. We know formula for VRMS and VDC, right? So here VRMS formula is Vm by root 2 and VDC formula is 2 Vm by pi. Substitute VRMS formula and VDC formula into this equation, then we got 2 Vm by pi. So VRMS is 2 Vm by Vm by root 2 VDC minus 1 whole square. So 2 Vm by pi Vm by root 2 total whole square. Okay, is there any cancel terms? Yes, Vm gets cancelled. So after simplification, this 2 square 4 and this root 2 square 2, 4 into 2 we got at the numerator as 8 and the denominator pi square, right? So that is why pi square, 8 by pi square minus 1. So this total value is after simplification, this total value is 0.482. 0.482 instead 0.482 in terms of percentage, that is 48.2 percentage. So here we got only 48 percentage of ripples is at the output side, whereas in half wave rectifier we got 121 percentage, right? 121 percentage means a lot of unwanted AC signals is at the output side. So compared to half wave rectifier, we choose full wave rectifier only. Ripple factor completed. Next, peak inverse voltage. Peak inverse voltage is the maximum reverse voltage before breakdown condition. So here we use a center tapped transformer. Center tapped transformer. For center tapped transformer, peak inverse voltage is a 2 Vm. 2 Vm. Peak inverse voltage is a 2 Vm for a full wave rectifier. Why? Because we are using two diodes. So maximum reverse voltage before the breakdown condition, the value of peak inverse voltage is 2 Vm for full wave rectifier. Next, transformer utilization factor. Transformer utilization factor means how much percentage of utilization of a transformer in the power supply. Okay, so center tapped transformer, for center tapped transformer that value is 0.693. Transformer utilization factor is 0.693 for full wave rectifier. Next, form factor, peak factor. We'll go for form factor, peak factor. Form factor formula, RMS value by average value. So RMS value means VRMS by average value. Average value means VDC, output value. So VDC, VRMS and VDC formulas. VRMS formula is Vm by root 2. VDC formula is 2 Vm by pi. So after simplification, Vm gets cancelled. So pi is at numerator and denominator is a 2 root 2. So totally we got pi by root 2 root 2. So for value of pi by 2 root 2 is 1.11. So form factor of full wave rectifier value is 1.11. Next, peak factor. Peak factor formula, the ratio of peak value to RMS value. Peak value means maximum amplitude. Maximum amplitude is Vm by RMS value. RMS value means VRMS. VRMS formula, already we know formula for VRMS, that is Vm by root 2. Vm gets cancelled, finally we got a root 2. So peak factor for full wave rectifier value is root 2. So this is the total explanation of full wave rectifier.